Welcome to EDU World Space.
Okay, in this problem we have light refraction. We have light rays traveling from air into some glass, and we have two different beams of light. We have light at one wavelength and light at a second wavelength, which I'm going to denote 1 and 2 respectively, because the wavelength doesn't really matter, but each has its own index of refraction through the glass, which does matter, which I'm going to call N1 and N2. When they were given to us in the problem, we know we're going from air to begin with, and so we're simply asked to find what is the refracted angle in both cases and what would the difference be between the two. So in both cases, we're going to just be applying Snell's law, which states that an air sine of the incoming theta. Oh, that's one thing we're missing. The incident light is hitting the glass at an incident angle of 60 degrees, which is uniform in both cases. So we're using that theta. So back to Snell's law, the index of refraction times the sine of the incident angle needs to be the same as the index of refraction of the second medium times the sine of the second angle, the refracted angle. So this would be the formula we would apply for case 1, and for case 2, we would have n air sine theta, so the same left-hand side, equaling n2 sine theta 2. So I'll show you how to do it for the first case, and the second case will be identical. It's really as simple as n air is just 1 sine 60 degrees over n1, which would be 1.4831. And we inverse sine both sides, and that will give us theta 1. So numerically, what that result turns out to be is 35.727 degrees. When we do the exact same thing for case 2, where we simply input n2, and yeah, that's really it. We end up with theta 2 equaling 35.943 degrees. So the difference between the two, call it delta theta, is about 0.22 degrees. So it's actually quite small. So evidently, light of these different wavelengths wouldn't have that big of a difference in its refraction, at least in the visible, which I believe these both are. So that's it, really just applying Snell's law twice.